All right. We're brand new. 15 lessons in on this, which I'm going to continue doing, and then eventually we'll get in there. Got some stuffs I want to add. Alright, so far you've come across two variables in the course which are vectors. Which are they? Position and speed. Oh no. Oh. Two? What? I mean, I know it's position. Scale, maybe? Yeah. Ugh, the terminology throws me off sometimes. Essential. Speed and direction. Calculate. Ow. This AI turtle below. Wow. They allow you to repeat a character's movement speed and direction, calculate the distance to a target, and more with little code. Take this turtle AI below you. Probably see games or enemies move. This is done with just 7 lines of pure vector calculation code. Code is a bit too difficult for now, so we'll spare you the details, but this turtle, Jesus, gives you a glimpse of what 2D vectors can do for you and your game projects. Level up. Cool. Okay. Using vectors to change the position. This is just addition of vector points. Move. Let's instant transmute. How would you move a robot 50 pixels to the left? We're gonna subtract, because this is XY, so it knows we're subtracting 50 from the vector point. So let's practice this. Alright, so what do we gotta do? Add a line of code to the level up function to increase the scale of the robot vector. 0.2 every time it levels up. Let me go back real quick. Position. They just created the position as a global prior, I guess. I assume that's what is the case here, so... Should be right. Beautiful. Correct. You completed the practice. Right. Wow. He's very big. The robot's level has increased a lot, and so has its size. Let's fix this by resetting the robot's scale and position value. Create the function named reset robot. The X and Y subvariables of the robot scale need to be 1.0. Scale. Then, robot's position needs to be at vector 2. Position. Reset at line 3, column 1. Invalid numeric consistency 0. Oh, I forgot a comma. That's why. The identifier position isn't declared in the current scope. Oh, I'm typoed. Beautiful. Exponentially beautiful. Lesson complete. Okay. What about while loops? My favorite. My favorite to create infinite loops. Because infinite loops are the most fun. You've seen that you can use functions to reuse code. In this lesson, you'll learn about loops. Loops help you repeat code. To illustrate how loops work, let's take a game board split into a grid. Our robot can move to neighboring cells by changing a vector to variable named cell. It represents the current cell the robot is in. When we increase cell.x, the robot moves to the right. Note that we delay the robot's movement in the app to help you visualize how it moves. The following code would normally move the robot instantly. Okay. Move diagonally by adding a vector 2 directly. So like 2. 1, 1, 1, 1. Same time. I mean, I don't know why you wouldn't just... That seems like a lot of work to just move diagonally. The above code works for predefined board with the size of vector 233, but the move to end function wouldn't work if the size of the board. Hello! If the size of the board was different. The robot would either stop before the end or go too far to implement a general solution for all board sizes. We can repeat the robot's movement until it gets to the end. For code that repeats, we can use loops. Use a while loop, which we know while loops are general loops. The variable number to keep track, blah, blah, blah. Each time we go through a while loop, we'd add 1 to the number. While loop keeps running for as long as the condition is true. In this case, it keeps running while the number is less than 4. You can see the following code is executed 4 times in the console. So we're... Number's less than 4, print number. Oh, well, yeah. Here. Why aren't the little guys working? Timed out? What do you mean? You connect, damn it. There you are, pals. Pals and friends. Little guys hanging out. Okay. Get the following code. Blah, blah. Let's apply this to our move to end function. This time, we compare the number of loops to the board's width. We go through the loop until we reach the width of the board. Note that we move the robot until... This is really basic stuff. What would happen if the computer tried to run the code above? Draw squares infinitely until the program is terminated. I don't think so. Draw 10 squares. Oh, wait, what? Oh. It's not adding. Missed that. Make sure when you're doing your while loops, you have a counter. Because if you don't, you're just it's gonna be a bad day. There's a safer kind of loop. For loops. Moving to the end of the board. Okay. Pass functions. First time I've seen one of those written on here. So our robot has decided to stand at the top of the board, complete the move to bottom function. So the robot moves to the bottom of the board. The board size is determined by vector 2 board size. Robot's current cell is vector 220. Make sure to use a while loop so the function works for any board size. Okay. Let's navigate that. While. Structure they used. I've completely forgot. While board size, right? Vertically, so it'll be Y. Alright. I hate not making my own variables here, but that's what makes me confused. So, while board 1, 2, 3, 4, 5. No, it'd be 7 if it's 2-0. Position. So it's .x. Then we would try that. Okay, that did not work. Oh, I know why. It's not X, it's Y. Okay, so that does not equal anything. Position.y. Did you increase its cell.y coordinate? Alright, so that's the problem. See, variables I don't know. So are we doing cell? Dot y is less than 7? No, 5. It was instant. It's to the bottom of the board. maybe? Oh, alright, dude. So you can go outside the board. I see. I understand. Okay. Last lesson, while we looked at while loops, we found that they were useful if we don't know how many times we should repeat code. However, they could result in infinite loops if we're not careful. The loop below never ends because we never increment a number, which is what I was talking about earlier with counting. It's a safer and often easier kind of loop to for loop. Yes. For loops are better. Let's change the code above to use a for loop instead. Ugh. What list of numbers would range 6 create? How to use for loops. In the above example, blah blah blah. Yeah, we know. So for those that don't know, those that are learning with me, and maybe have no idea when it comes to code, your number always starts at 0 when you're talking about a range and ends the number prior to the number you said. So for instance, if you said 5, it'd be 0, 1, 2, 3, 4. If you said 7, it'd be 0, 1, 2, 3, 4, 5, 6. Basically think of 0 as the new 1 and then count up from there. In both examples, we print the value of temporary variable we created, number, in the first example, the element, second. Godot moves through the loop. It assigns each value of the array to that variable. First, it sets the variable to 0, and then to 1, and finally to 2. Okay, I get it. So for variable array, element equals array 0, print element equals array 1, print. Okay, so why you could just do that? Oh, they're not doing it in a loop. Okay. They're giving you a visual example of a for loop, which I appreciate. Okay, so we can put whatever code we like in a loop's code block, including other function calls like draw rectangle, using a for loop instead of a while loop. Okay, function still works the same. You can execute it below. Okay, so function move to end for number in range board size dot x minus 1. Tell that x plus equals 1. Okay. Using a for loop to move to the end of the board. Proving code with a for loop. Okay, we're gonna do it. Once again, the robot has decided to stand at the top of the board. This time use a for loop in the move to bottom function. To have it move to the bottom of the board. Board size is determined by the vector 2 variable. The board size of the starting cell is vector 2. 0. So what are their variables again? Board size dot x. They use cell dot x, I guess. So for number and cell size dot x, we'll try. Or cell dot x, I think it was. For number and why? I understand, but come on. Cell dot okay. So are we doing board size now? Did we change our variables? Trainer. We did not. Okay. Did you increase its cell dot y So just sell. I don't. Okay. All right. I'm not gonna argue. Not gonna argue. The for loop to remove the duplicate code in the practice. We turtle drawing for loops. Space. Horizontal square should be 100 pixels apart. Okay. Well, we'll try that. Oh, I know. Or do I? Because you'd want the function to run thrice. So we could make a variable. Counter. No, that's a while loop. We want to do a for loop, which should be for. To be for number in range. Let's see. Oh. Syntaxical. There are fewer than 3 shapes we can't. Okay. So I guess it is 3, even though it shouldn't be, but. Perfect. Success. The range function we saw in the previous lesson outputs a list of numbers. For example, range produces the list of numbers 0, 1, 2. Yeah, okay. Syntax of arrays. Understand the syntax of arrays. If you do not, this is it. Always brackets, regular brackets, commas to separate each value. Follow a path. Look at the widespread use of arrays in game. Finding and following a path in game. Need allies or monsters to find their way to their target, whether it's the player or some point of interest. To achieve that, we use pathfinding algorithms. As the name suggests, those algorithms find the path between 2 points that allows AIs to traverse the game. Many of these algorithms use arrays of vector 2 coordinates to represent the path. Take this turtle path. It wants to follow the robot, but there are rocks in the way. How can we tell it where to walk to each to reach the robot with an array. Path to robot equals vector 1, vector 2, vector 2, 1, 2, 2, 3, 2, 4, 2, 5, 2, 1, 2, 2, 1, 2, 2, 3, 2, 4, 2, 5, 2. Every value in the array is a vector, represents a cell the turtle needs to walk through. Together, all the values in the array represent a path we can draw. In the upcoming lesson, you will see how you could use arrays to store player inventory, design attack combos. For now, let's practice creating arrays. Let's. Okay. The turtle wants to meet the robot, but it cannot find it on its own. Fill the turtle path, indicating where the turtle should move to avoid obstacles and safely arrive. Move up, down, left. It can diagonally copying and pasting. Fill the array with comma separate. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. First one. 1, 1. Then 2 through 5. 2. Why did we space there, Trav? Jeez. Only 5, 3. Should work. Beautiful. In this tactical game, the player and computer can select units at once. You need to function. As an array is a value type, the computer recognizes you can pass the whole array as a single function argument. Select all units on the board by passing the correct array to the select units function. Okay? Vector 2. Vector 2. Oh. Vector 2. 4, 3. And vector 5, 1. Oh, it's 4, 2. Oh, me. You are 03, aren't you? Yep. You got me with the 00. There. Goof. goofy. Okay. Range function in combination with for loops. A range function produces an array that the for keyword could loop over. We can give for loops any array and they will loop over them just the same. Instead of using the range function, we could manually write the numbers and get the same result. Each element inside the array, the for loop extracts it, stores it in a temporary variable named number, and executes the loop's code once. Inside the loop, you can access the number variable, which changes on each iteration. The code works regardless of the array or where you store it. Often you will store arrays and variables for easy access. Yeah. What will this code print? It should print 0, 1, and 2. Make the turtle walk with a loop. In the previous lesson, you made the turtle walk along a path by writing vector 2 coordinates in an array. It's a for loop that makes the turtle walk along the path. The loop works like this. For each coordinate in the array, it moves the turtle once for that cell. It's the same principle with the unit selection. For each coordinate in the array named selected units, we check if there is a unit in that cell, so we select it. In that case, we use an array, a loop, and a condition together. Look at all that. The code above uses several features you haven't learned yet. Well, I do know these, but I don't know the engine, so I'm learning the engine's language. For those that are curious, this is a Python-based scripting language, so it's, if you're looking at the indentation and the syntax, it's virtually identical. I mean, instead of def, you're using function, but other than that, I don't think you have the variable call. You do not have the variable call in Python. You could just do units equals and it would create a variable itself. So this is a variable call out, but I think it just makes it easier to read in terms of game development. The code above uses several features you haven't learned yet. In a condition, the in keyword allows you to check if variables exist in an array. The array's append function appends a new value to the end of the array. Yeah. Notice the use of a period after the selected units variable to call the append function because this function exists only on arrays. Excuse me. When functions exist only on a specific value type, you write a dot after the value to call the function on it. We'll revisit those two features again in the following lessons. The beauty of loops is that they work regardless of the size of your arrays. The code just works whether you have 1 or 10,000 units to select. It is all accomplished with only a couple lines of code. That's the power of computer programming. In the following practices, you will use arrays combined with for loops to achieve similar results. Okay. Our AI pathfinding algorithm provided the path for the robot to move to the right edge of the grid. Your task is for loop to move the robot. Call its move to function like so. Robot.to move to function only exists on the robot, which is why you need to access it this way. Okay. Your task is to use a for loop to make the robot. Or vector. And robot to vector. Doesn't have to be. Guys, or no. In one 2, 3, 4, 5, 6, 7. Global variable, why is that not? Q. Okay. Let's check the docs here. Turtle that move to cell, right? Or cell in path. But they don't have it. They don't have it structured that way. You have global functions for cell and cells. I wonder if I can do that. I wonder if I can run robot for vector path. Robot dot vector. Too few arguments for run call. Expected at least one. There is one. I stumped. I don't know why I can't call a variable there. I should be able to call these like I should be able to do it like this. Robot for path. The starting point, and then this would be the ending point. I should be able to progress like this. But they won't let me call a robot path. It's a global variable, but it won't let me call it for some reason. For vector. It should work the exact way that I'm doing it, because each of these would be a vector. It would go in order. So robot. That's the way it should work with a global variable here. This should assume that each one of these is a unit in the array. This, and then so each vector it should push through the entire for loop until it's done with the entire array. Which I don't know why. Okay, so it's working fine. I don't know what I did wrong the last time. Okay, the variable rectangle sizes. So we want to draw a mini rectangle, something surprisingly common in games. However, writing this code by hand can get tedious. Instead, you can store the size of your shapes in arrays and draw them all in batches. Let's practice rectangle sizes array with the draw rectangle function. It shouldn't overlap or cross each other. To avoid that, you need to call the jump function. Alright, so 4 rectangle in rectangle sizes. Okay. We want rectangle jump. Rectangle call expected at least 2. I explain. This whole class of errors has to do with calling functions. Either the wrong number of arguments or the wrong kind. You will need to use the error message to see what's going on. Remove, add, or change the values you're trying to pass to the function to solve this issue. You know how many arguments you need. Check the code reference, which I don't have that code reference right now. I literally can't stand the fact. One of the things I don't like about this teaching software is that it doesn't store functions and variables in a way that makes them easy to access. I don't know what back when we did this length, float, height. But those numbers are stored in the vector point. So it should default to 2. Guess I'll try to repeat rectangle twice, maybe. That didn't do shit. You want me to throw in the length and the float, or length and the height, right? But those are stored in the vector sizes. So like, why can I not just call the vector through? like, what the fuck? Change it. It probably won't work, but yeah, expect at least 2. That's fucking stupid. So let's try this, I guess. Nope. Just out of curiosity. No. That's literally terrible. I don't understand code scripting. Maybe it's dot draw. What? The vector okay. That doesn't seem right, but there you go. Do vector x vector. Oh, now they're overlapping. Definitely do it. I just can't figure out why I would have to call that when the vector is already stored. The entire coordinate is already stored there. Those rectangles totally overlap, by the way. Strings, my favorite. Throughout this course, we mostly stored numbers and variables, but what if we wanted to store a player's name? This is where strings help us. Strings are instrumental in games and applications. We use them to display information such as description, a spell, or a name, or the name of a character. What are strings? A string is a value type which holds text. To create a string, you write text wrapped in quotation marks. For example, this is a text string. Quotation marks different strings. Run. Robot. Under the hood, strings are arrays of characters. In fact, we can use a for loop to loop through the characters of a string. Yes, we can. The piece of text you see in this app is a string that Godot is displaying for us, much like how vector2 variables make calculations easier. String variables come with many helper functions and tricks we can use. We can use arrays to store things too. This is useful for chaining animations. In this example, the play animation plays a specific animation. In the next few practices, we'll use strings in combination with different concepts from earlier lessons. Okay. Currently, the robot has a number stored. Root name variable. Change the robot name variable so that it's a string instead. You can give it any name you like. Jeff. Run. Perfect. Array of strings to play a combo. In this practice, we chain together animations using an array of strings. You might find such combinations in fighting games. A robot has the following animation names. Jab makes the robot perform a quick punch. Uppercut. Robot uses a powerful jumping punch. Populate the combo array with animation names that has strings. Then, for each action in the array, call the play animation function to play them. The array should contain 3 values, so the robot makes 3 attacks, 2 jabs, followed by 1 uppercut. Okay. Strings. Jab. Okay. 2 jabs followed by 1 uppercut. Combo isn't correct. Did you use the right actions in order? Jab, jab, uppercut. Okay. Combo. Oh, you're right. I really don't understand why I have to make this a for loop. through it twice. So it's acknowledging that there's two there. I literally don't even know how I would go through this in a for loop or action in combo. Play animation action. So it literally what I'm doing. I see. Guys, I'm actually going to take a little break because I just got some news that I don't really like. So I'll be back in a couple hours.